Hello, my name is Ian Walker, and I'm here to talk about two of California's most beautiful national parks, Pinnacles and Redwood. Although located in the same state, the two parks and their origins could not be more different, showcasing California's amazing diversity. During this project, I will discuss both the park's geologic features and history. Pinnacles National Park is located about 40 miles east of Monterey. It is a desert well known for its amazing geographic features, including its spires, ravines, and caves. Native Americans have inhabited the area near Pinnacles for over 10,000 years. When the Spanish arrived in 1769, the natives were slowly eradicated by disease or conquest. The land's natural beauty led it to being made a national monument by Theodore Roosevelt in 1908. Much of the park's infrastructure was built by workers during the New Deal. The image in the lower right corner shows people working on the Chalone Peak Trail. It was reclassified into a national park in 2013. The story of Pinnacles begins 60 million years ago when the Farallon Plate subducted the North American Plate, as can be seen in the MPS graphic on the left. This process led to a massive buildup of sediment, which would become California's coastal mountain range. The subduction also opened up fissures which allowed magma to escape, as seen in the graphic on the right. This created the Pinnacles volcanic field near modern-day LA 20 to 23 million years ago. After the subduction and subsequent volcanism had stopped, the Pacific Plate collided with the North American Plate, leading to the creation of a transform boundary between the two, shown on the left side of the slide. The collision also created the San Andreas Fault. The transform boundary tore off a piece of the Pinnacles volcanic field, moving two-thirds of it 195 miles north of its birthplace. The image on the right is a Google Maps image that shows the distance between LA and Pinnacles. During its journey across California, most of the volcanic field sank between the ramparts at the San Andreas and Pinnacles fault line. Most of it was buried until the ramparts were eroded, exposing the field to wind, rain, and ice. The erosion that followed created the ravines, mountains, spires, and caves that Pinnacles is famous for. The image on the left shows the spires and pinnacles, which are made from volcanic rocks carved by erosion. The image on the right shows one of the park's talus caves. These caves were the result of massive boulders being wedged in between ravines, which were further eroded by floods and rockfalls. Pinnacle's elevation ranges from 824 to over 3,000 feet above sea level. On the left side of the slide is a geological map provided by an article published by geologist Andrew Alden. The pink on the map is of the Mesozoic basement rocks, including Santa Lucia granite and granodiorite. These are the oldest rocks in the park, going back 78 to 100 million years. They were created by magma cooling under the earth, but were exposed to the surface by erosion. The red section shows the Pinnacle volcanic rocks, created by magma that came from the volcanic field. The rocks include rhyolite, andesite, and dacite, the last of which forms many of the park's spires. The park has three main faults: the Pinnacles, Miners Gulch, and Chalone Creek faults, the last of which is still active. The San Andreas Fault is currently 4 miles to the east. Now we move on to Redwood National Park, located in the northeast California near Humboldt County. It is famous for its titular redwood trees, shown in the picture on the right, the left. Native Americans have lived in the Redwood area for over 10,000 years. The forests were devastated by the gold rush of 1850. The image on the right shows the Falk Lumber Company of 1897. The vast destruction of the forest raised concern among conservationists who formed the Save the Redwoods League. The league purchased large amounts of redwood land to keep it safe. These lands were made into state parks in the 1920s. By 1960, 90% of the forests had been destroyed. It wasn't until 1968 that the national park had been created. In 1978, the government added 10,000 acres to the park. In 1980, the park was made into a UNESCO World Heritage Site for its biodiversity and historical value. Redwood National Park is located in the most seismically active part of the country. During the 90s, there were at least 9 earthquakes of 6.0 or higher. The park is 100 miles northeast of the Mendocino Triple Junction, which is a meeting place between the North American, Pacific, and Gorda Plates. The frequent earthquakes lead to landslides, changing rivers, and coastal erosion. The 3 largest rivers of the park are the Smith, Klamath, and the Redwood Creek, shown on the right. These 3 rivers have eroded much of the bedrock near them, creating deep gorges. Most of the park's geology comes from the Franciscan complex, which is composed of Jurassic and Cretaceous rocks. The map on the right shows the diversity of the area's rocks and the different periods they come from. The coast is essential to the geology of the park. Much of the rocks are brought by uplift from the ocean by plate tectonics. The rocks are a diverse collection of sedimentary rocks, including sandstone, siltstone, and shale. It also hosts metamorphic rock, including chert, greenstone, and schist. Climate change is a dire issue not just for these two parks, but for all of California. Rising temperatures will disturb precipitation, which in turn will disturb natural habitats, according to Climate Change and California's Terrestrial Biodiversity, a paper done by PNAS.org. Changes in weather patterns will disrupt California's biodiversity. Rising sea levels have led to more erosion on the coast and threaten to destroy over $7 million worth of infrastructure. According to the Pinnacles National Monument Action Plan, a small temperature could alter precipitation, fire patterns, and organism habitats. In conclusion, Redwoods and Pinnacles are beautiful national parks that showcase the ecological and geological diversity of California. They also show the necessity of combating climate change, lest we lose these amazing parks to unnatural disasters. Let us hope that we can protect these amazing landmarks from those who wish to destroy them for profit.